Hello distance learners, welcome to day 2 of geometric probability. Make sure you have a sheet of paper out so you can take your notes. Let's get started. Question 1, geometric probability. Remember from yesterday, geometric probability is just our desired area divided by our total area. So example 1 says a skydiver is on a secret mission. A skydiver on a secret mission has a small area that he must land in. In the diagram, the area in pink shows where he must land. What is the probability that he makes his landing? So in this case, our desired area is the pink spot in the middle there. So the desired area, remember we called that our dA, out of our total area, TA. Desired area is 12 by 36. The total area is 40 by 100. If you multiply those out, 12 times 36 is 432 square feet, divided by 40 times 100 is 4,000. 432 divided by 4,000, 0.108. Multiply that by 100, you find that you have a 10.8% chance of landing in the pink spot, the desired area. Well, if you have a 10.8% chance of landing in the pink area, then the rest means that you would miss the pink area. So the next question says, what's the probability that he misses his landing? Well, percents are out of 100, so if I take the 100% and I subtract out the 10.8% that I actually land where I want to, that'll figure out how often I'll miss, which would be 100 minus 10.8, 89.2% of the time I will miss my landing. Try another example. A dart is randomly thrown at the figure. Find the probability of the dart not hitting the purple, which means we want to find the probability that it actually hits green. Not purple would mean we hit green. Well, in this case, we have a square and the purple is a big circle, so we have to take that circle out of our green square. So if we find the entire square, that's going to equal 16 times 16, because the length and width would be the same. So the area of the circle is 256, the area of the square is 256 inches squared. Now I need to take out the circle. The circle, that's pi equals the radius squared, so 3.14 times my radius. Now I know my diameter is 16, so my radius is 8, so it's going to be 8 times 8, because radius squared is the number times itself. So the area of the circle, pi times the radius squared, 3.14 times 8 times 8, I get 200.96. So now what I need to do is take my circle, my square, wow, that's just some really bad spelling there. Square, S-Q-U-A-R-E, minus my circle. So it's going to be 256 minus 200.96, and that's going to get me my green corners. Which equals 55.04. So my green corners, that's my desired area. So I take my desired area, 55.04 divided by my total area. And the total area here was 16 times 16, that's the whole square, 256. 55.04 divided by 256, I end up with a probability of 0.215. I multiply that by 100 to get it as a percent. I have a 21.5% chance of landing in those green corners, of not hitting the purple region. Try another example. This diagram is the largest model of a sunny side up egg. In the live model, the artist made an equally scaled pepper grinder that drops flakes of pepper on the egg. Made an equally scaled pepper grinder that drops flakes on the egg. What is the probability that the pepper will land on the egg yolk? So the yolk is the orange or yellow part there. So think about it, you're dropping pepper. Okay, I'm dropping pepper, boom, 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 boom. What's the probability that my pepper, the black little dots I just made, lands on the yellow part? So my desired area is the yellow part, so the yellow circle. So the yolk, that's going to be 3.14 times the radius squared, so times it by itself, compared to the whole egg, the entire egg, which is going to be 3.14 times 10 squared, 10 times 10. So multiply that out on your calculator. On the bottom you'll get 314. On the top you'll get 200.96. Divide that out on your calculator. 200.96 divided by 314, and you should get 0.64, or a 64% chance that your pepper will land right there in the yolk. Last example. The image below is a replica of a carnival game. You close your eyes and randomly throw a dart at the board. If you hit the blue, you lose. What is the probability you will win? Well, if blue means that I lose, then white means that I win. So I want to hit the white. A win equals white. So the first thing I need to do is figure out the area of the white. So what I need to do is figure out the whole area of the rectangle, and then I need to subtract off all those blue circles. Well, the rectangle is just 36 by 18. So if I multiply 36 by 18, I get 648. That's the entire rectangle. Now the circles, notice I have 18 circles there. I have 18 of them. But each circle is going to be 3.14 times 3 squared. 3 times 3. So each little circle is 3.14 times 3 times 3. So what I need to do is figure out each little circle. It's 28.26. 3.14 times 3 times 3. But there's 18 of those little circles. So what I need to do is I need to take 18 and multiply it by 28.26. That'll figure out my entire blue area. So 28.26 times 18. The entire blue area, I'll write it in blue so that you know that it's the blue area. The entire blue area is 508.68. Now, I want to figure out the white area. So what I'm going to do is I'm going to subtract those two numbers to figure out the white area. Because the white area is where I win. So if I take 648 minus the 508.68, the area of my white spots is 139.32. So my winning spots are the white, it's 139.32. So my win, my desired area, divided by the entire area, which I found that's the whole rectangle, 648. Type that in your calculator. You get 0.215, which is, when you multiply that by 100 to find a percent, 21.5%. So, if you randomly drop a dart in the carnival game, you will win 21.5% of the times. It means that your dart's going to land in one of these white areas here, not on the blue. If you have any questions, reach out to your teachers. Watch the video again. Good luck with more geometric probability.